Hello, my name is Emily Marangoni, and today I'm going to be giving a presentation on the components needed to do a forensic comparative analysis. During forensic examinations, both objective and subjective analysis are used to varying degrees. An objective analysis includes comparative measurements, such as measurements of dimensions of an object, with these measurements being done with respect to how the objects relate to each other. The techniques that are used to collect and record evidence can also be considered to be objective forms of analysis. Subjective analysis is seen in the application of these techniques and in the interpretation of the results. While the conclusions should be based on objective evidence, the scientist's training and educational background will also contribute to the outcome of their analysis. Over the course of a forensic scientist training, they will use 3 types of logic when examining evidence. These 3 types of logic are deduction, induction, and abduction. The first type of logic that I will discuss is deduction. This logic type is taught to forensic scientists when they are in school and in training, with the progression of the logic being from general to particular details. This is summarized as case and rule, therefore result, which in an educational setting would be seen as the examiner or student being aware of the images being from the same source or not, and individualization or exclusion is possible because the features are unique and persistent. I have an image on the right side of the screen depicting a question footprint being compared to a test standard, which in the case of the previously described scenario, those involved would already know that the details of both impressions will agree with each other. The second type of logic that I will review is induction, which could be summarized as the inverse of deduction. This type of logic progresses from particular to general, where the results and the case determination are used to ascertain the rule according to our textbook. This type of logic is uncertain as the persistency of the sources cannot be proved, so therefore the rule cannot be ensured. The final type of logic that I will be reviewing is abduction, which combines concepts from deductive and inductive logic. Abductive logic is the type that is used in actual casework, with the progression described in our textbook as starting with the understanding of sources being unique and persistent, followed by a comparative examination, and then a determination of if the images are from the same source. The result of abductive logic is a case, with the inductive logic being able to relate the case to the rule, and its relation to the result is then reasoned with deductive logic. This progression is summarized as rule and result, therefore case, which is based on the rule that if the rule and result are true, then the case will be true. This is why abductive logic is not probabilistic in the way that induction is. For an example, I've included an image of a latent print, which is a print from an unknown source being compared to a known print. So this is the type of evidence that would be examined using abduction logic. Objects have unique features, with these features falling under 3 categories. The form of an object is the general shape, which can be used to tell if 2 objects are similar. An example of this would be comparing an object that is more rectangular like a brick to an object that is more circular like a ball. Their general shape would then be able to exclude them as being from the same source. A pattern is the structure of a shape within an object. This feature is more specific than form and is found within an object that has a form. Persistency refers to the pattern's structural ability to last. While every pattern is unique, no pattern is permanent. This lack of permanency is because a pattern can be changed or damaged. During a comparative analysis, persistency is required to individualize an image. The features of every object is unique, with all natural patterns also being unique. While unnatural patterns might not seem unique upon initial examination, as they are looked at with increasing level of detail, unique patterns will be identified, allowing for the individualization of the image. As an example, I've included an image from the textbook which depicts circles of varying colors grouped into a rectangle. The general shape is rectangular, the form, but the shape of the pattern consists of circles which are arranged in a way that depicts the letter E. I found that while this image does not necessarily explain persistency, it does provide a simple example of form and pattern. Objects can be classified as being either natural or unnatural. Natural objects are like the name describes and are found and made in nature. Unnatural objects are, on the other hand, man-made. Unnatural objects are able to have their shapes determined with molds or other tools, and they can have symmetrical or asymmetrical forms. Natural objects can also have symmetrical or asymmetrical forms, however, the natural pattern is not capable of symmetry. Like I previously mentioned, all natural patterns are unique, and this includes patterns at the molecular level. Unnatural patterns can also be unique at such a level, but will also acquire changes to their features. This can occur through the features chipping or breaking, such as paint chipping off of stairs or bits of a tool breaking off. I've included an example of both types of objects. I used a snowflake for the natural object as it also displays a symmetrical form, and the production of shoes for the unnatural object as it displays how shoes can share overall shape, color, and dimensions through the use of machinery. Continuing on with our discussion of natural and unnatural objects, natural objects can have unique natural patterns. These natural patterns will never be repeated and are unique to that object. I previously mentioned that the form can be generally symmetrical, but the pattern cannot. Instead, the pattern can have almost perfect symmetry or be asymmetrical. Developmental noise is what causes this break in symmetry, as natural patterns will have variations caused by various influence. These can be things such as the temperature or chemistry involved in the pattern formation. Unnatural patterns are able to be repeated due to them being man-made, with features to a certain degree being able to be repeated within a certain set of dimensions. However, while they can have repeatable patterns, they will also possess unique patterns either beneath the surface or through the wear of the features. When describing the form and pattern of an object, there are going to be different levels of detail used. While there can be more than 3, we're just going to be using 3 for the purpose of this presentation, with the subsequent levels being subunits of the previous one. The details within the first level are going to be used to describe the general form and shape of the object. This level has the least amount of significance and quality in comparison to the other levels, but is a determining factor in the amount of quality and significance present in the other ones. This level of detail does not allow for specific measurements, but does allow for the exclusion of an object being from the same source based on the general shape, such as the brick and ball example given earlier. The visual example I provided on this slide is an overall photograph I took for a crime scene course in 2023. I use this as an example as the overall photograph will be the most general photo taken to document a scene. The second level of detail allows for specific measurements to be taken and includes a description such as the dimensions, paths, and positions of details within the pattern. This level of detail is a subunit of level 1 and must exist within the first level. These details have an increased level of significance and quality than level 1, but are limited by the quantity and quality of the previous level. Following the example on the previous slide, I included a mid-range photograph from the same scene. So this one is going to be closer to the select evidence items and display their relation to each other, but is limited to the area previously depicted. The final level we will be talking about is level 3, which is a subunit of level 2 or a sub-subunit of level 1. This level of detail includes the edges and contours along the path of the patterns present, among other features. Similar to level 2, it also must exist within the boundaries of the previous level, so it can only exist within the second level patterns. Also similarly, its details are more significant and are of a higher quality, but are limited by the quantity and quality of the previous levels. And concluding the photography example is a close-up photograph of one item of evidence, the most detailed of the 3 types of photographs used to document a scene, but was limited by what was present in the overall and mid-range photo. All of these components are taken into consideration when a comparative analysis is being conducted. Both objective and subjective analyses are used, with the objective analysis including information like the measurements of dimensions of a pattern, while the interpretation and conclusion of the analysis are subjective in nature. This interpretation is done through the use of different forms of logic, with the deductive form of logic being commonly used in a training setting, while the abductive form is used in a more practical setting. This logic is then employed while the forensic scientist is examining the features of an object, with these features contributing to the scientist's ability to both classify and individualize the object. These are the references for the content that was discussed and the images that were attached. Thank you.